In previous video, we have seen dynamic characteristic of the system, and before that we have seen static characteristic and what is measurement, the definition of measurement. In today's lecture, we are going to see what is an error. If we see any system or any instrument, if we take reading, it's not so perfect. If we take an ideal system, we might have perfect reading, but in any daily routine, in any experimental system, we do not find reading so accurately or so precisely. This is because of error. We have seen the static error and the dynamic error, in which we have seen the error is the simply concept of the actual quantity or true value and measured value. Measured value minus true value is called error. But when it comes to function of time, it is known as a dynamic error. But here we are going to see gross error, random error, and systematic error in detail. So what is error? When we do experiments or use technology, we need to measure things. But no tool can measure something so perfectly. This is small mistake is called error. So, error is the deviation of the measured quantity from the actual quantity. Error either could be positive or it could be negative. First, we will see systematic or constant error. A systematic error is a consistent, repeatable error associated with the faulty equipment or biased measurement techniques, which always affects the measurement in the same direction, either always high or always low. If a voltmeter is miscalibrated and always read zero point 0.5 more than the actual voltage, all voltage readings will be higher by zero point 0.5 volt. This is systematic error. When we work with any system, sometimes the system itself produces consistent error. Why? Because there is some mistake in the instrument or its calibration. Systematics error are consistent and reproducible in nature. We have seen what is reproducibility. The ability of any system to reproduce output in different conditions. In systematic error, there is always direction is fixed or either always positive or always negative. Systematic error can be detected and corrected through calibration and improved techniques. Systematic error affects accuracy but not precision. So let's discuss the types of systematic error. Systematic error, instrumental error, environmental error, observational error, and theoretical error. So, what is instrumental error? If we see any instrument which is calibrated imperfectly, worn out, so it's known as an instrumental error. Environmental error occurs due to external conditions like temperature, pressure, or humidity. And what is observational error? When we observe something incorrectly or by incorrect methods, like we call it parallax error, is also known as observational error. And the fourth one is theoretical error due to simplification or assumption in formulas and models. The last error, theoretical error, means when system is mathematically modeled and there is a mistake in formula. Due to that, reading goes false. And this error is called as theoretical errors. Now let us discuss what is random error. When we work with any system or any instrument, when we take readings, there is always any unknown error which we don't know, and why it is happening we don't know the cause. So these errors are known as a random errors. Random error is an error that occurs by chance and causes small variation in measurement even when the experiment is repeat under same condition with the same instrument by the same person. With a high quality instrument and careful observer, small changes in a reading can still occur. These small changes have no clear causes. This may be due to minute change in environment, manual handling, and internal fluctuations in instrument. You measure the length of road 5 times and get like 100.2, 100.3 centimeters, 100.1, etc. Even though everything is done carefully, the values differ slightly. This is called random error. Random error occur unpredictably and without a known reason, as we have discussed. The magnitude and direction vary commonly. We also don't know. It might be positive, it might be negative. Random error cannot be eliminated but can be reduced by taking multiple readings, calculating an average, and affect the precision of the measurement. Random errors are the error which we cannot eliminate totally from the system because our system is not ideal system. So what we can do? We can take multiple readings and taking average, and random error affects the precision of the measurement. Now, what is gross error? Gross errors are big mistakes in measurement that happen due to carelessness or lack of attention by the person doing experiment. In a system, the experimenter who is taking readings, he or she might taking false reading or taking wrongly reading or not reading the instrument correctly, using wrong units, doing experiment in too much hectic. So due to all these reasons, the produced error is known as a gross error. If the true reading is 20.5 but the observer write it 25, so it's a gross error that is caused by human mistakes. These errors are not due to instrument or environment. They do not follow any rule or pattern. It can be avoided by being careful and alert, double checking readings, and follow proper experimental procedures. When any experimenter do any mindful reading, so it can be eliminated. What is absolute and relative error? Absolute error means measured value minus true value. And what is relative error? The percentage of absolute value upon true value is called relative error. What is guarantee error? When we buy any instrument, there is sometimes written guaranteed error or limiting error. It is nothing but the instrument, how false the instrument could read. It is the maximum allowable deviation from the true readings. Okay. It represents the worst case scenario of the error that can occur in measurement. So it is expressed as a percentage of full scale. Limiting error is the maximum allowable deviation from the true value specified by the manufacturer. What is propagation of error? When you calculate a value using measured quantity, any errors in those measurements affect the final result. This is called propagation of error. For getting output, suppose we use two inputs, and every input has their own error. So this is known as propagation of error. If you measure values A, B, C, etc. with some errors, the resulting value computed using A, B, C will also have an error, even if the formula is the correct. Propagation error is the effect of input uncertainties or inaccuracy on the outcome of a function, formula, or system when these inputs are used in further operations. If you measure length like 5 plus or minus zero point 0.1 centimeter and width 3 plus or minus zero point 0.1 centimeter and the calculated area equal to length cross width, the individual measurement error propagates to the final area, increasing the uncertainties in the result. Now we can see the addition, subtraction, and multiplication of the propagation error. This is the square root of delta A square plus delta B square, or in a case of multiplication or division, square root of delta A upon A whole square plus square root of delta B upon B whole square. For powers, relative error in Q is equal to mod n cross delta A upon A. Propagation of error is commonly tested in instrument measurement and physics-based questions. It helps to determine the accuracy of calculated result in real system. Here we can see what we have discussed in a formulatical way. Very basic concept is significant figures. We all know and we have gone through in a physics also. It reflects the precision of the measurement. Non-zero digits are always significant. Leading zeros are not significant. Trailing zeros are significant only after decimal point. For more clarity of concept, we have discussed the difference between true value, measured value, and the error. What is error? Measured value minus true value. If error is a positive, it's overestimation, and if error is a negative, it's an underestimation. True value means actual or ideal value of the quantity. Measured value means the value obtained using the measuring instrument, and error means the difference between measured and true value. We have here examples of the true length of the road is 100 centimeter. Using a ruler, you measure it 98.5 centimeter, and error is the difference between 98.5 minus 100. It's a 1.5 centimeters. So in this lecture, we have discussed what is error, what is gross error, what is systematic error, what is random error, what is propagation of error, what is absolute error, what is relative error. Here I have discussed very basic concept and useful formulas for any examination or any concept clarity. But for understanding better error, we have to go for calculations.